So we are really happy to have Karik, who is our third-year student. Did some nice work, really nice, about low resource machine translation, and Karik is officially supervised by Rita, and Rita grabbed me on the boat because my PhD was machine translation, I guess.
Thank you.
Yeah.
Once again.
Yeah, so I try to help on this, and he will present what he has been doing, experimental sightings, and some interesting output. And we also submit ICR demo paper we just managed. Fingers crossed for the outcome also. Welcome, Karik.
So I guess I can start. So welcome to our presentations, and I'm going to present CANTONMT. So it's basically a platform for Cantonese to English translations mainly, and basically by using like different fine-tuned model and with real and synthetic back translation data. Okay, so in this today I will talk about like different aspects of it. So from motivation why I do this project, and to what data I use and what model I use, and the pipeline of the back translations, and then the evaluation results, and also a demo for the user interface. So for motivations, because I'm from Hong Kong, so my native language is Cantonese, and it's basically one of the most popular dialects in Chinese language. And the word Canto comes from Guangdong, which is a province in China. And there's quite a lot of people speaking Cantonese all around the world, in Hong Kong and Macau, in Guangdong, and even in mainland China. And for machine translation, it's always been a task that is being used for a lot of language, but then for some language like low resource language, just as Li Feng has said, it remains a big challenge for people, to researchers, to fine-tune the model. And especially for Cantonese, it's not really been explored by researchers. So in here, I want to make some objectives. So first of it is to investigate the back translation method. So basically by doing some synthetic data, and then doing the model fine-tuning to make the model better, and introduce like Cantonese into English as a new language pair for more systems, hopefully. And I want to do some evaluation against some commercial translators for my models, and also to compare with different metrics too. And at the end, I did a user interface just for people that wants to use more, like want to fine-tune more models in the future, to have like a toolkit for them to display the results easily. So here are some related works around like different machine translation tasks, especially on Cantonese. So for Cantonese to English, which is what I'm doing, we got some like example-based and rule-based machine translations from like 2006, which is a very long time ago. And there's a plan it's on the website on Hong Kong University, but then there's no little results to show is it good or not. And for different commercial translators, we got Bing and Baidu that supports Cantonese. Baidu is a company from China, if you have not heard it before. But then for Google and DeepL, it doesn't have Cantonese, it just have Chinese as a language. But for the opposite direction, English to Cantonese, there is sort of a GitHub repo, which did the whole research on like how to do it. But then they haven't published a paper yet, so.
You only find one repo, right?
Yeah.
So it's just still very less work on this.
So it's still very less work on it. And in like a sort of similar way for Mandarin and Cantonese, so Mandarin is basically Chinese, but in this case, and there are some like different models that have done it before. Like there's like some dialect base. I'm not sure what does it really do but it's like a very old paper. So assumingly it shouldn't be that good, and they don't really have like proper metrics to measure it. So I'm not sure on the results on them. And for for the recent work, there's like transformers and LCM based. Again, they don't really yield the best results. So with that in mind, I just try to use like back translation because it's a very popular technique used in like different statistical machine translations and neural machine translations. So like here are some papers that does that before, but then none of them focus on Cantonese English related. So that's why I'm doing it right now. So after that, I collected some data. So initially, I just got like one data set, which is from Hong Kong, and it is 44K in size. And so I split it to 48K for trainings and then 3K each for development and testing. That's because like normally share tasks in WMT, it's have like 3K in test sets. So that's why I split it like this. And in like the latter stage of my project, I find there's like two more different data sets, including Wenlin, which has 14.5K more, and Opus, which has 10K. So combined with that, I did some more fine tuning at the end. And for the back translation, we obviously need like a monolingual data sets for both sides. For English one, it's quite simple. There's a bunch of resources out there. So I used the one in 2012 news in WMT. And for Cantonese, it's not really there. And so that's why I did some web scraping in this forum. It's called LYKG, and it's a very like popular forum in Hong Kong. You can sort of think of it as like the Hong Kong Reddit. And basically I have different categories that people can chat on it as a forum. And I extracted around 1 million sentences. And after the cleaning and also some anonymization of data, and then also I filter out short sentence because I don't really need that much sentence. So if its sentence have like less than 10 characters, then I'll just remove it. So at the end, I use 200K only for the synthetic data generations. And so this is like an example of it. So I basically just use the text part, and then like let's say here to somewhere here. And then if it's got some URL, just remove it, and to check if it's 10 words or more, then I will just put it in the data sets. And I did some, and then for model selections, I choose 3 models. So one of them, it's NLP, which is the main one I use. It's the only LLM, I think, that contains U and N, which is Cantonese to English as a language pair. And it's a very recent model from 2022. And for different models, I wanted to like investigate like the model size. Does the model size matter that much? So I chose Opus MT, which probably have some Cantonese data inside in the pre-training. But it's a very relatively small model, like it's like 10 times smaller compared to even the distilled version of NLP. And another model I chose is MBARS, is because this is a model that does not really have Cantonese as a language pair. For the pre-training data, I'm not sure if it has Cantonese, but I would assume there shouldn't be much compared to like NLP. So that's why I chose it for just to investigate, does that make a difference? And the first part is for model fine-tuning. And basically, I just trained each model with the gold standard data or the real data that I got from before. So the worst Hong Kong data set. And after that, this is the whole pipeline for the back translation afterwards. So this is the fine-tuning part. And then after that, I used the fine-tuned version to put in some sample sets, put in some data sets, some sentence from the monolingual data sets I got. And then I trained it, and I put it in the model for like the synthetic data. And then after that, I just have the 200K parallel synthetic corpus, and then the real corpus, the real parallel corpus. And then based on it, I choose a ratio. So let's say this is 1, and this will be like 1, 3, or 5, as you can see in the later slides. And then I fine tune with different LLMs too. So basically the Opus, the NLP, and MBARS, and we got the fine-tuned version of the synthetic data inside. And after that, we just do some evaluations, which we did for metrics, for score comments, for embeddings, and lexical, it's Sacred Blue and HLPOR, which is from Big Bang.
Okay, pause here. Anyone about the pipeline not clear or don't understand?
The fine tuning of one of the fine tuning of synthetic data set. So what is that? Why do you do that? So what are you tuning there?
Okay, so
In
firstly, from left right top down, right? Here is the real data that the currently found.
Yeah.
But it's only 44K he found available globally
Yeah.
in the first stage.
Not much.
Yeah, so he divided trend validation and test, right? He used this limited real data.
Yeah.
To fine tune the existing model, right? Then he got a fine tuned model.
Yeah.
But he also scraped a bigger amount of data himself. That is modeling data.
That's how we go. Yeah.
So this data was expected to help the model training because it is larger than this, much larger than this. We have collect more modeling data is cheaper online, like that, right? And then so with this feed into the fine-tuned model,
That model. Okay.
then here you can generate a fake or synthetic parallel.
Okay. So synthetic in the sense that it is still a standard, right?
Yeah, the half real another side is generated.
Okay.
And then with this bigger data,
And
he can totally remove this as well, but because it's real data, so it's valuable, so he keeps this and add a different ratios of parallel synthetic data to retrain the model.
Yeah.
Here can be the same model or can be different one. Later he will talk about the model switch because if it's the same model, it might have some bias, then it can be different model. And then after this training with larger data, then test it.
So what's being fine-tuned is the model.
on what? So that's tuned on this synthetic data that you call it synthetic plus,
Yes.
Plus some real.
and it might be a different model than the other blue box, right?
Yes.
That's what you're
So
saying.
later there
That box and that box might be different boxes.
Yeah.
Right, okay.
So this RRM and this RRM doesn't need to be the
Doesn't
same.
really the same.
It can be the same one, but it can be different one to and people call it model switch, right? So
Okay.
then later there's the evaluation part.
Can I ask?
Yes.
Maybe it's coming up, maybe I've missed something. This isn't back translation, right?
Yes.
Where's the back translation there? Because back translation, you translate forward and then you translate back, right?
So
I don't see translating back. I
So
see
technically,
translating forward.
in the results I did back translation to,
Okay. But
but
it's not on
then
this slide.
for back translation, because the first initial ones, the results is not that good for the back model. So basically what happens is that the back model doesn't perform much worse with more synthetic data, like let's say the ratio is 1:0. So at the end, potentially, maybe in the future, we can probably do it iteratively. So let's say we do two more cycles, then this part basically might come to play more.
Okay.
But still, there's some back model I trained that's using the Cantonese data.
Will you go on to discuss that, or is that?
Yeah, I'm gonna
go for that. Then I won't ask any more questions. I'll let you explain it.
That's a good one. Thanks.
Questions in the chat maybe as well.
Either. Now because we can hear you can also shout out, okay? Online.
Okay. Yeah, may I ask a question?
Yes, okay.
So after you have the synthetic data, have you done any filtering or checked the quality of the synthetic data?
I didn't really do any filtering on the synthetic data. I did have a look, and some of them might not be the best at the quality, but then I still put it inside for training, just so it shouldn't be because after if I just do the filtering myself, then I think it's not a fair test. So that's why.
Yeah. Yeah, please.
The quality of the synthetic data is you can view the quality indirectly by the evaluation score that he will show you. So after the real data training model, right? The synthetic data generated by the first fine-tuned model, right? And the first fine-tuned model is also evaluated in the evaluation matrix. So you get a general score with that. But that's because I thought about it, like how we evaluate maybe we can put the synthetic data in human evaluation as well. That was, yeah. Yeah, but you will see some scores later about the synthetic, yeah. That's a good question.
Yeah, and for the ratio, if I understand it correctly, is it you have different proportion of synthetic data and the real data? Is that true?
So it's proportion. So like, let's say I will always put the 38K in for the fine tuning. And then depends on the ratio. Let's say it's 1:1, then I'll just put 38K here and here, like randomly sampled. And then
Okay, so with a fixed total amount, right?
it's not a fixed total amount. So if it's 1:1, it will be 76K. If it's 1:3, then it will be 100 and
Whatever that is.
How many?
150.
So you keep all the real data, but you have different proportion of synthetic data. Is that correct?
Yes.
And no, not all. There's also half.
Yeah, there's 1/2 that we did, and that's 38K.
Yeah, you should watch out for the big table. There's one coming, yeah.
Okay, thank you.
It's basically diluting the real data with the synthetic data, right? So you're adding.
I have a question.
Yes.
I just want to ask, when you fine-tuned NLP, did you find it in both direction, English to Cantonese, or only one direction? I mean, both or just one?
I mainly focus on one direction for the fine tuning.
Okay.
But what you're suggesting is that basically turn it just the other way around and start from English original, translate that to Chinese, and then repeat the whole story. Yeah.
Yeah.
Fun.
It depends on your eval set, right?
Yeah, if you can have that, yeah.
Yeah.
But you do have, right, I guess, parallel corpuses.
So,
Yeah.
Abdul, do you have suggestions? Abdul is doing a PhD of machine translation, low resource as well.
I just as the one who asked about back translation should be from the target to the source, because you want the target always to be clear, not synthetic. But maybe this will also produce some results. I don't know. And for fine tuning, NLP it's multilingual, so maybe adding other language related to Cantonese might also help. I'm not sure how Cantonese is as a language. Is it has similar languages others, or just it's a unique language?
You mean Cantonese? Then it's basically have like a lot of like different code switches. So, like let's say, I'm not sure.
I guess the question is, if I understand correctly, if Cantonese has related languages, which I think is the case, right?
Then yeah, it will be Chinese, I guess.
Yeah, other family. Abdul is asking because he's working on Arabic dialects. So in Arabic, you have like, I don't know, 20 different dialects. So his point is that if you, instead of just feeding the model one of the dialects, you can actually, the performance might actually improve if you include the other dialects because of some similarities and so on. So I guess his question is it the case for Cantonese?
That's good. So we can add more. So I can. So Cantonese is a Chinese dialect from Canton, from Guangdong province of China. So Mandarin is also a dialect of Chinese from Beijing area. So
But it's dialect, it's not a different language, right? It's a dialect.
yeah, it's same language, but with kind of with some sort of code switch, because there are different ways to express.
Yeah, we can understand Mandarin, do you?
But then it's like I would say for Mandarin, like what you say, like it's Chinese, it's basically Mandarin, and because it's basically the biggest one. So
But Cantonese.
but Cantonese is like much different, I would say. But it still has the
If
same.
you speak Mandarin, would you understand Cantonese?
Do you understand?
Not fully. For the writing, not fully. For speaking, it's totally different.
Yeah, speaking.
It's not really different.
Yeah, speaking different,
We
but
have some input from the chat, which might be useful.
Okay, go back to the example, the script, the source type.
It's interesting. It's different languages, right? Okay. Because then we shouldn't be saying that they are dialects.
Yeah.
So here, so Mingyang, you speak Mandarin, right?
Yes.
Can you understand?
不剧透。
Real time.
I know.
By the way.
That's a Mandarin.
Who speaks Mandarin?
后句你必过有最强行。I can't understand the meaning of the.
Okay.
So it basically means like no spoiler. Which movie have you watched has the biggest twists? It's
I can understand a bit more than Mingyang. I lived in Macau for 3 years, but yeah, I'm left. Yeah.
So shall we read comments?
Yeah.
Yes, then we should see what Dimitri said.
I think they're completely different.
Dimitri, you don't want to shout out.
I think it's
So we
just
can
use the same script. Probably
It seems
similar.
we
but
have
not
empirical
the
evidence that Ming Yang.
Yeah, exactly.
That's just some
Mandarin
theoretical.
is a language family with some varieties not mutually inclusive. Yunnan Mandarin is usually considered not mutually inclusive with Beijing Mandarin.
There you go.
That's very knowledgeable. I didn't know anything about Yunnan Mandarin.
I think there's a form of standard Chinese, right?
Maybe hallucinations.
I think Mandarin is a standard.
yeah, I think Mandarin with the standard Chinese that people talk about. Not so.
But then there are dialects within that differ.
Even in Mandarin, there might be some dialects. I think.
北京
We are hitting a very sensitive topic.
Exactly.
Okay, so Fuji said, okay, Fuji makes a work. Fuji, do you want to speak?
Well, in Cantonese.
Sorry. I always get confused about the classification. I thought like in Yunnan and it's like in Liverpool people have different words, and in London people have different words. Those are dialects.
Yeah.
But I'm not sure what makes a dialect different from a language, because Cantonese and Mandarin and Wu, these are like they have different grammars rather than words difference.
So does anyone have a definition of dialect? Yeah.
We need Dimitri.
Dimitri, it's a
Dimitri.
tough question.
Dimitri, what's the definition of dialects in linguistics?
Well, the general definition that people use in practice is usually mutual intelligibility. And when people describe two varieties, if people from these two communities can easily communicate, even though there are some differences, then these will be dialects, for example, like London English and Liverpool English. But if they cannot communicate anymore effectively, then it's more likely that these two varieties will be considered languages. So yeah, it's really complicated with Arabic and Chinese. They're both called dialects, even though they're actually language families. So in Arabic, most varieties are actually mutually intelligible. At least that's what people tell me. So basically people from Morocco and North Africa, they cannot really speak to people from Qatar. So Gulf Arabic and North African Arabic are different, but inside these two groups, everything is more or less mutually intelligible. So there are basically two large dialect/language groups. In Chinese, it's even more complicated, but in a way easier, because there are high-level groups like Mandarin and Wu and Cantonese. They're definitely completely different languages, which are completely mutually unintelligible and have been diverging for like 1,000 years now. They're very old. But there is a problem that there is Mandarin Chinese, which is also a very large language group. And most people in China now speak some variety of Mandarin. But if you look at actual descriptions, and people will tell you that actually people who speak Mandarin in some provinces like Yunnan and Sichuan, they won't be able to talk to people from Beijing when they're using their own Mandarin, not the standard language. So Mandarin in itself is also actually a kind of language family, but they're all called dialects because this is just the traditional way of doing this. Yeah, so there is always this, and people want Chinese to be a single language, right? Because China is a large country, they have a single nation, they want to be a strong, single, unified nation. So people from China don't like very often to talk about the fact that they have several very distinct language groups.
Okay.
That's why it's easier to apply to dialect, right? Yes, we have a Chinese language with a couple of dialects, yes.
Okay, so Dimitri, your point about mutual intelligible is the verbal communication, right? Not the written one.
Well, when you have a unified writing system, it helps. It helps both in the Arabic case and in the Chinese case. In the Chinese case, it helps even more because you can basically write the same words without using like any kind of grammar, right? You can just use lexical items in some order, and then people will understand you. So the question of mutual intelligibility with the written language is completely different. And yeah, like even a Japanese person not knowing any Chinese at all, as long as they know enough Chinese science, right, they can communicate. But you won't say that the Japanese is mutually intelligible with Chinese on the written level. I mean, you can say that, but it'll be a bit weird.
Okay, thanks for the feedback. Good. That's the benefit to have a linguist.
It's Abdul's fault.
Yeah.
Now it's carrying time.
Yeah,
Continue, Karen.
okay.
So
So no
after
more
like, yeah,
sensitive questions.
In case we upload to YouTube later.
Only technical questions.
so basically after the normal back translation parts, I did find some more data. As
Not much, right?
So
40K
so that's
and
24K more. So it's like 50% more, I would say. And I did the fine tuning and I put it into evaluation too. So then it will be some learning curves here. And the main point is the evaluation. So just some like acronyms I use here. So BL here stands for baselines. So basically it's just the one that has the gold standard on the real data inside for fine tuning, and synthetic data is the one that contains both real and synthetic data. And the ratio behind it, it's basically, if it's 1-to-1, then it will be 38K and 38K. And then the model switch here, basically this will be the main model. So I'm using NLP for fine tuning, but the synthetic data is coming from MBART. So that's basically the gist of it.
so from here, you can see the half, right? Before the 1-1 ratio. So to substitute the half of the real data with synthetic data, the score didn't drop much, right? Actually, it's quite similar. Especially other score not so Sacred Blue has a 1-point drop, let's say from 16.5 to 15.7. But H-Lab per score and Comets, they have very similar scores when we replace half real data with the synthetic data. So that also says something about the quality of the data, at least for this training purpose.
So yeah, I guess we'll continue. So yeah, it's like some findings based on the evaluation results. And so basically it's with synthetic data and real data, it's generally better than just real data. So it's the case for NLP and MBART. But then if you look at the different ratios, if the ratio keep on increasing because the data is probably less quality, and the result basically drops quite significantly. And same for MBART. Remember here.
What is HH?
Oh, HH is half and half. So
Is that not the same as 1-1 though?
no, half it's the
Smallest.
38K, then we'll just do 19K and then 19K synthetic data.
You can replace HH with 0.5, 0.5.
Yeah.
You can't have a, sorry.
So the first line is the original.
Baseline.
Because then
Baseline, or BL baseline.
1-3 then wouldn't make sense. So
Yeah, 0.5 pixels. So, but then it's not the case for Opus. And it might, because it's a small model, but then maybe the quality of the data just hurts too much for the small models compared to a big model where there's like more parameters to train. So it doesn't really fit on the bad data that much.
That's a good point. We didn't write in the paper. That's the quality of the data hurt the small models, and the bigger model maybe can tolerate the noise in the synthetic data.
Let's see, is the top line NLLB forward BL, that's without any fine tuning.
Oh, that's
Just
with,
baseline or so.
oh, that's with fine tuning. I
With
guess.
fine tuning.
Yeah, I guess.
You see the base.
So
Go back
I guess
to,
it's here.
fine-tuned
This
on.
would be the one without.
go
no
back to the
fine-tuning.
bigger tape. Go back to the big. Back.
Ah,
Yeah.
okay.
So
So
here's
that's fine tuned on the
one, two,
initial
three,
data,
four.
and then you've got the fine tuning with the synthetic data. Okay.
So this for cluster, this is actually, so this fine tuning. Here's model switch. Here's model switch with one part, model switch with this, and fine tuning with model switch. And here's the three commercial one. So this kind of like first experimental comparison. And then this is at working more real data, what will happen. And this is at another thinking what will happen. And here is a deployment without fine tuning. You will see the score is much lower if we just deploy it without fine tuning these three models. And then Eric will go to all these four cluster. Yeah, this first cluster that you just mentioned.
So another thing findings, I would say it's the model switching part. It matters quite a lot. As you can see here, like let's say for NLB, if we do the MBAR data, it got like 0.2 increase in Sacred Blue and in all metrics too. It improved slightly. And it's the same case for I guess for MBAR, I didn't really train it on like the just MBAR data. But then it still sort of gets improvements here. But for Opus, it's the same case where basically it might be just a small model, then it might just hurt the model too much for the bad data. And I'll go to the point of like just compare with the deployed version. So basically the one you can find a Hugging Face easily. Then it's basically got a massive improvement in all aspects. So it might not be the fair comparison for MBART and Opus because it's Chinese, not Cantonese. But for NLB, they say there's like language pair of Cantonese to English, but still it's not the best results compared to the fine-tuned model. So that's the findings here. And then against like different commercial translators. So for GPT, it got a much higher scores than like our models.
The GPT-4 here is not prompting. It is a fine-tuned GPT-4 by a community called the Cantonese companion.
It's a custom GPT-4.
Yeah, it's a custom GPT-4 bot. So is it fine? I don't know if it's fine tuning. It's sort of fine.
Particularly for.
Yeah, particularly.
It might just use some prompt to build it. I'm not quite sure on.
But you don't have the details.
Yeah, I don't have the
because
detail.
some
It's
sort
not.
of, one of these GPTs, which are just.
It's like in a
You don't know where it came from, basically.
in a point also that we don't know how much data they use to fine tune, and the data is not probably available to researchers.
And sometimes if you use GPT, it's just unstable because it might just not give you the correct results, or it just dies in the middle. So, but for our like models, then obviously it's your model. You can just basically simply just put it in to production easily. And then for Bing and Baidu, they have like similar results as you can see for Sacred Blue and all other metrics. So Bing is slightly better than our system currently. And then Baidu is like worse compared to Bing and even to our models. But then later on, like after that, we got like the more data part. And for just fine tuning with all three corpus, so it got 50 something K data at the end. It's produced like a much better results compared to the baseline. I didn't put it in, but even comparing with the one that's the fine-tuned ones with synthetic data, it's better than it by a quite significant margins. So I think what it means is that if we do the process once again with more data and basically the ratio could be the same and we can get more synthetic data in, then potentially like the performance could outperform the Bing 1.2. So that's the point here I would make. Yeah. And then here I'm just going to talk about just the general gist of the interface that I made.
Sorry, going back to the score. So actually with this stage, with this around 50K real data, the fine-tuned model, the evaluation score is better than Microsoft Bing and Baidu already. So the goal can be, if we get better synthetic data quality, it could be better than GPT-4 model in the performance. Right. Okay.
So it's just basically the general flow of the servers, if anyone's interested. And I'm just going to show you demo for now. So, lots more thing. But yeah, so basically for the interface, we can choose from 3 models. It's quite easily expandable to different models too, if you want to. And we can choose from Cantonese English because I trained both ways for the back translation part. And here you can choose the different types of model. I didn't load all the models in, but all the models are available on GitHub or in a Google Drive if you want to have a look yourself. Yeah, I'm just going to give some examples. So this is one of the sentences in the test sets. And so this is what the best one do. So the one with just fine tuning with gold standard data. And this is the output here.
Choose another model.
And if I choose another model, here's my level. Let me just wait for him. But then we can compare it to the actual one. So let me just switch it. Should we 5.1? Just didn't put it up. So it's this sentence.
Is it internet connected or is it?
Oh, I didn't put it up. So this is the direct translations here. I'll just put it here. So it's quite similar.
Did you not? What did you share? The whole screen or only one?
I just shared a Chrome tab.
Remove this sentence. English. You didn't share your Chrome.
Yeah, this is the gold standard data. Yeah.
Oh, yeah, that's.
Yeah, I just didn't share a screen for them.
You just wanted to show the reference, basically.
The reference, yeah. Well, so first. Can you read it maybe? Yeah.
I'm also like screaming like.
Read the output.
Okay, so I'll read in Cantonese, okay?
Yeah, you can do that.
So
Mandarin would do that as well.
there's a semantic difference between the two, right? So one says because he didn't disclose information, and the other says in order not to leak information. So the intention is different. So which one is it in Cantonese? Is it because he didn't or in order not to leak
So
information?
this is the gold standard, so it's basically this one.
That's the correct.
Okay.
marker.
So sorry, can someone read it, right? So I'm struggling to see it. Can you just make it at least
Bigger.
Oh, bigger.
bigger?
Zoom in.
Yeah, oh, thank
there
you.
go.
Yeah, yeah, that's fine.
Font 17.
Don't overdo it. This order was captured by the enemy army because he didn't disclose information. He generously was generous.
I mean, even that would be
Generously is a very
strange.
strange word in there,
Even that
yeah.
is strange.
It doesn't work in the sentence.
Yeah.
What is it in Cantonese? Does it have this word generously or some cognate?
Because of his generosity, he got
Oh,
killed.
Like they executed him.
He got executed.
There's Chinese idiom
Yeah.
here. There's a
Actually-
means how to say? Usually means somebody died for some bigger good. Let's
So
say.
glory.
But the thing is, the use of the word generously makes more sense in the translation because it says he generously gave his life to the enemy. I mean, that in itself makes sense, right? Although as you said, the intention is wrong,
Yeah,
but in a way, the use of the word generously is somehow more correct there.
So, yeah, it's an interesting example also that the model answer is perhaps less correct than the other one, right? So generously executed sounds.
Yeah, what the gold standard translation created?
Oh, it's from Words.Hong Kong, so it's
Someone like visually set and translated by. Is it like
I guess the question is if it's manual, if it's gold standard, would you consider it gold standard because it was manually?
I think it's manually.
Oh,
I
was
would say.
But I suppose they mistranslated the idiom there.
Yeah,
As,
It depends on the quality of the manual one.
Almost glorious, yeah.
Probably gloriously.
Go another engine. I want.
Yeah, that
I'm
one.
curious
So
what the other engine.
let me just typing.
But was that sentence been a part of the training set?
Oh, it's testing.
Okay, so it wasn't.
So it doesn't.
Okay, let's see B.
In
Soldier
general,
was captured by the enemy in order not to leak information. He was killed by the enemy.
Probably captures the sense. Is again
So it's
an idiomatic.
Yay.
It's interesting.
And we can go to
So idiom translation is still
It's a big thing, right?
multi-word expression.
I need to
You should get this submitted to MPU as well. You can
I mean,
have a double submission.
we missed the.
We already have transferred over.
You're the organizer.
But then in GPT,
Discuss this as an example, right? So
Okay, let's see in GPT.
GPT is
We bravely sacrificed himself.
Oh, there's another explanation.
So he
More hallucination.
sacrificed
Yeah.
was killed by
so
the.
this is better, right?
Well, you don't know he sacrificed himself. You don't know he sacrificed himself, but that's some extra information that's introduced.
Oh,
Yeah, he can't sacrifice himself, but he was just killed.
Yeah.
We don't know, maybe he did, but that's some additional.
What is the original say? The original meaning, he offered his life or what?
the soldier is killed by the enemy,
Yeah.
but then it's basically this part. So that's the sort of like
What is the leading information? The first two.
Describe the meaning, the meaning of the.
Wrong. Wrong, it's means.
Practice a visual representation.
Okay.
Universal language.
Okay, so here with the context, actually he sacrificed because in order not to leak information, he knows some information that
Was he offering to be killed? Or it was killed, right? So
No, he was
killed, right?
Yeah, so then sacrifice is wrong, right? Well, maybe it's
you
not.
mean whether he offered himself to be killed or they decided to kill him.
He sacrificed. It says that there's some action on the agent, right, which isn't in the
So
original.
this, I think this idiom 慷慨就义 is Chinese, right? If the enemy either kill you or you tell something.
so it's
So
like
it's like
in the
uh,
order sense.
it's not, so the other side is easier. They won't kill you if you don't compromise.
Right.
Yeah.
Well,
Yeah, am I correct?
Yeah.
Okay. Good, let's try to finish. Not delay.
to find a better example.
Yeah, I know,
Less than.
it's difficult to explain the example.
So that's basically what I discussed before. So it's just like one way we cap it. But then for the future work, that's what I said before. So we got some module data, so we can basically run the pipeline again and see if it's better in the future. And also for evaluations here. So we are going to plan out to do some homemade evaluations to basically will be the best performing models. So I'm not sure is it going to be the new one or the one that we got currently. And then we got the Bing one, so which we just saw, and GPT-4. And we use this metric. And
Data privacy important to measurement.
so because our system's like open source and basically we can get it easily without running it on other machines. So if it's you're handling like different sensitive data like clinical data, then it helps for the people that's using it. And also the platform is open source for the user interface you just saw. So and then basically people can just get more models in and maybe potentially even more language in. So yeah, that's basically it.
There are more slides.
Some leads, right? Glad that.
Yeah, that's the main point.
Yeah, that's a span to read the full paper. Good. Good job. But this I use this. I don't. More questions?
I was going to ask about human evaluation, but you put it on the slide. So
Yeah, human evaluation is to do.
I was
Jeremy,
gonna ask, I know that's based on your
the
prior
human,
work, yeah. But roughly how many people need to be involved, and or is it more like, you know, like when you evaluate, like, let's say summaries, you have these different metrics, you know, like, I don't know, grammaticality, coherence, and even, so is it a bit similar?
Mhm.
Or-
go to the link, you have the hope metric link in the page.
Good paper, I guess.
I guess my question is, if you do one because Henrik only has the A player.
Yeah.
To do
So,
human evaluation.
Yeah, there is this predefined error categories with a grammatical error included. And there are also mistranslation style error. So this category was designed by Serge because he's from industry background. This
Right.
is summarized from, I say, historical project errors. And then basically the human evaluator, we expect they can locate different error types.
Mhm.
So we can give more insight for error analysis. But all these error categories have a severity level. You can choose is minor error or is a severe error
Mm.
when the evaluator score each.
I see.
And in the end, after you finish this categorization, you will get a summary, let's say.
Mhm.
Because, for example, Microsoft Bing and synthetic data have similar evaluation scores, but they might have errors in different categories. So we can say, okay, the blue score is similar or same, but this make
one
grammatical error.
Make errors for this.
Yeah, and that make terminology error. So this is kind of insight for,
I see.
and we can have a quantitative analysis with that.
Nice.
And yeah, that's the idea.
Okay, thank you.
And to get human annotated agreement level, so we need to make sure like each sentence have two scores
Yeah.
from different person.
Yeah. So then we kind of need to find obviously at least two people or more.
So yeah, two more people will be better.
Okay.
So
I want to just find out like how long does it take to do the
Yeah,
one-
exactly.
the one,
There's
two.
quite a few categories there. So.
Yeah.
Okay.
Yeah, the goal is to judge around 200 sentences. And
So,
if it's too
okay.
much, we can try to make 100.
Okay.
Because we had another paper about uncertainty, like the analysis says that 200 sentence plus can probably reflect the system without a bias.
I see what you mean.
Yeah, because 100 sentence, it might be, okay, this 100 sentence I think did better, and then another 100 did worse.
Got it, yeah.
So there's statistical significance.
Mhm. Okay.
Put online people back. There are more questions online as well.
there was a message in the chat. There's a question on it.
Or the side, oh, sorry. I like the idea of titrating
You can do
the synthetic information. Well, what does this titrating mean?
Oh, I was just commenting that it's interesting that it's in different ratio. Titrating is the chemistry of adding things, just like yes.
What about fine tuning? Yes, yeah, tuning. Yeah. You can call it tuning or titrating. Oh, there you go.
Oh,
Yeah,
Change the title, yeah.
This is lexical simplification.
Or complication.
and the slides are tidy. Great job, Tom.
Okay, camera.
It's interesting that you mentioned that, right? I wanted to ask a general question, right, in the last minute. So You have, like in many other presentations, tons of details and numbers. Is that what you need to have in the presentation? So you have tables with 27 columns each, and rows, sorry, and 4 columns. Do we need that for the presentation?
You may this one on.
Generally. So you can read it.
So that's why I split it.
You can read.
No.
So that's why I try to split it off to like different
Yeah.
tables.
I mean,
So
apart from being too small to have a look, right? You know, if you go back, you have even larger tables.
this one.
Yeah,
Yeah, that's what I meant.
This one is-
Giant table.
yeah.
I just want to put it so it's just like a
So
sample.
where do I, when I listen to your presentation, where do I look?
So that's why I want to split it off to this one.
Mhm.
It's just to give you a feel of
The
the.
general comment we discussed.
So my rule of thumb is on a slide, every piece of information on the slide, you should spend 1 minute on that slide.
Mhm.
So on this slide, you have 1, 2, 3, 4, 5, I don't know, 20, 30 rows there. So 120 minutes to explain the slide.
It's just original. I want to just to mention the different like.
You want a bird's eye,
acronyms.
you want to give a bird's eye view of everything, and then you want it to. I guess that's fine, but as long as you clarify that we're gonna zoom in on each part in the succeeding slides.
And not spend time on it, right?
Yeah.
One of the things
Always-
there, you have 2 options. You try to go through that table and try to find something interesting, and then not listen to you,
Yeah.
or to check my email. That was the option. Right? And
I don't think it's a criticism of you though.
No,
sorry.
it's a judgment
Sorry,
thing.
we had
The general way
on our
you
PhD course this morning, so I'm still
Oh,
in
okay.
that-
Go ahead.
in that mood
Yeah.
of criticizing people's presentations, right?
The other
We
thing,
had that as a
I don't know if you do that or if you advise that, but one feedback point I got before is that in a paper, it's okay to have tables, but in a slide presentation, go for like something more visual, like charts,
Thank you.
bar graphs, and so on. I don't know if you say the same. I don't want to contradict what you say in your.
No, I said it's not really a rule, and
Yeah,
I'm glad that Matt mentioned rule of thumb, right? So I'm not sure whether it's a rule, right? But you know, everyone has its own rule. It's just what's practical, right?
Yeah.
So I get annoyed by big tables. Sorry, not on Wednesday afternoon. One thing that we also concluded after our discussions, it wasn't too many people, but still, I think it was interesting, was that it is good to give these presentations in a small group first so that people can tell you these things, and that we need to develop this culture that, well, yes, I can tell you now without having any particular problem, say, oh, look, this is a small table, I can't see it. Right? Rather than you go to a conference and then people
Yeah.
have a problem with that, right? So
Okay, let's hope this paper will be accepted, and then in the conference presentation,
I think that's
We're-
positive spirit.
replace the tables with the chart.
yeah.
Yes.
Yeah, so I would rather just highlight a couple of things and say, okay, look, the things are going down, right? So I don't care honestly whether it's 15.73 to 8 or 15, whatever. I think that the point that you want to make here is, well, it's going
This is
down.
better.
It's going down as you add more, as you titrate more data, synthetic data, and it's go up the other way, something like that, right? So, yeah, and if someone is really interested in numbers, off you go. There is a paper, or there will be a paper, there's a paper on archive, go and read to 7 decimal places.
Very good
Do we
hook.
even need slides?
to read the paper.
Do we even need slides?
Well, I don't know. I mean,
We don't need them.
again, sorry, I got frustrated because not many people turned up.
Oh, so you wanted to.
Because there are more people now than.
Yeah.
So the point that I'm trying to make, yes, it is, what we all do is you copy things from your paper and put in the slides.
Oh, yeah.
And the most frustrating thing is when you have a bigger 7. You can, right? And I found yesterday, did I send it around? I think I did send it around. Someone asking GPT to write an introduction.
Yes. I'm sure I'd love to write an introduction on your topic. Great. In like a Springer journal.
In a journal, really published, right? So
Yeah.
right?
It's like on chemistry maybe.
Yeah, well, I can't remember now, but it's